PG Upgrade is Postgres's major version upgrade tool, and it's ridiculously fast because it does something clever. It doesn't copy your data when you use link mode. It works with a new cluster you've already initialized, migrating catalog data while reusing existing heap files when using the link option. But that speed? It comes with gotchas that'll absolutely wreck you if you're not ready.
Wait, it reuses the actual data files. How does that even work across major versions?
That's exactly what we're going to whiteboard today. We'll walk through the catalog swap mechanics, the link versus copy trade-off, and the classic post-upgrade traps, missing statistics, extension mismatches, and collation changes that'll silently break queries. All right, let's start with how PG Upgrade actually pulls off an upgrade by working with a pre-initialized new cluster.
Right, because one might assume that upgrading requires a full dump and reload, but PG Upgrade avoids that by transferring data files from the old cluster to the new one you've already set up.
PG Upgrade requires you to first initialize a new cluster with initdb for the target PostgreSQL version. It then migrates the system catalog, all the PG class, PG attribute, PG index rows, to that new cluster. It preserves your table and index OIDs so it can point the new catalog at your existing data files. The heap files and index files themselves, they don't change format between most major versions, so Postgres can read them directly.
So the new cluster is just a fresh catalog pointing at the old cluster's files?
Exactly. That's why it's so fast. The old cluster's data directory stays on disk. You can even keep it as a backup until you're confident. But this catalog swap approach is also why certain things don't carry over automatically, and why some post-upgrade steps are mandatory. PG Upgrade keeps your schema, your roles, and your tape spaces. It preserves table and index OIDs so the file mapping works, but it does not carry over query planner statistics. PG statistic is rebuilt empty. It also doesn't preserve WAL files, replication slots, or logical replication subscriptions.
So after the upgrade, the planner has no idea about data distribution?
Right. Every table starts with default statistics, no column histograms until analyze is run. That's why the first trap is missing statistics after an upgrade, and we'll come back to that. The point is, PG Upgrade is a catalog operation, not a logical dump, so anything that lives outside the catalog or is version specific doesn't transfer.
You mentioned link versus copy. What's the difference?
That's the second big decision you make when you run PG Upgrade. It controls whether the new cluster hard links to the old data files or makes full copies of them. With link, PG Upgrade creates hard links from the new cluster's data directory to the old cluster's files. It's instant and uses almost no extra disk space. With copy, it makes full duplicates of every heap and index file, which takes time proportional to your database size and doubles your disk usage temporarily.
So why would you ever use copy if link is faster?
Safety. With hard links, the old and new clusters share the same physical files on disk. If you start the new cluster and something goes wrong, or you run a vacuum or e-index, you've modified those files, and the old cluster is no longer a valid rollback target. With copy, the old cluster's files are untouched, so you can roll back cleanly. Link mode is faster, but it's a one-way door.
So if you use link, you can't go back?
Not safely. You should take a final base backup before you start the new cluster if you're using link. Most production upgrades use link because the speed matters, but you need a rollback plan that isn't just restart the old cluster. Hard links only work if the old and new data directories are on the same file system. If your tape spaces are on separate mounts, each one must also be on the same file system as its target. Some network file systems like NFS don't support hard links at all, and copy-on-write file systems like btirfs or ZFS may not give you the space savings you expect because they clone blocks on write.
So in cloud environments or with remote storage, you might be forced into copy mode?
Exactly. Always test your upgrade path in a staging environment first. If link fails, PG Upgrade will tell you, and you'll fall back to must copy, which means you need enough disk space for a full duplicate of your data. Now let's talk about the traps. The first one is the most common and the most immediately painful, missing planner statistics after an upgrade. Running analyze after an upgrade is essential to refresh statistics.
Because PG upgrade does not include statistics in the upgrade process, it's important to run analyze after the upgrade to refresh statistics.
Immediately after PG upgrade, statistics are not transferred, so you need to regenerate them. There are no column histograms, most common values lists, or correlation stats until you run analyze. The planner makes decisions based on defaults, which means it'll choose sequential scans on multi-million row tables because it thinks they're tiny. Queries that were fast before the upgrade can suddenly take minutes.
So you have to run analyze on everything before you put the new cluster into production?
Yes, PG upgrade tells you this in its output. It generates an analyze new cluster script that runs analyze on every table. You should run that before you cut over traffic. For large databases, use vacuum DB, analyze in stages, which analyzes in 3 passes with increasing statistics targets to balance speed and accuracy. Here's a real example. This query looks for shipped orders for a customer. Before the upgrade, it used an index and returned in milliseconds. After PG upgrade, the planner estimates 10 rows and picks a sequential scan. The query scans millions of rows and takes nearly 2 seconds.
Outdated or missing statistics can contribute to this by leading to inefficient query plans.
Exactly. Once you run analyze, the planner sees the real row count and correlation, and it switches back to the index scan. This is why you must analyze before you serve production traffic. Otherwise, your first hour post-upgrade is a performance disaster. By the way, my DBA's free health check continuously collects explain plans and PG statements data, and it flags query plan regressions and missing or stale statistics across your cluster. After an upgrade, it'll show you which queries got slower and whether it's a stats issue or a plan change. You get the first report almost immediately, and it keeps growing over the first week, grading you across 16 domains with the exact runnable fixes.
What about extensions? Do they just carry over?
Not always. Extension mismatches are the second big trap, and they can be subtle. PG upgrade checks that all extensions in the old cluster are available in the new cluster, but it doesn't automatically update them. If an extension's shared library isn't installed in the new cluster, the upgrade will fail. If the extension version in the new cluster is incompatible with the new Postgres version, you'll get errors when you try to use it. And some extensions require you to run alter extension update after the upgrade to apply schema changes.
So you need to make sure every extension is installed and up to date before you upgrade?
Yes. Check the installed extensions in both clusters with select asterisk from PG extension. For third-party extensions like PostGIS, TimescaleDB, or Citus, make sure the vendor has released a build for your target Postgres version before you start. And read the extension's upgrade notes. Some have specific steps you must follow. Extensions like PostGIS have their own upgrade procedures. After PG upgrade, you need to run the PostGIS upgrade function to update the PostGIS system tables and functions. TimescaleDB has specific pre- and post-upgrade steps documented in their upgrade guide. PG Partman might need you to refresh partition metadata if the catalog OIDs changed.
So it's not just install the extension and go?
Not for complex extensions. Always read the extension's documentation for the target Postgres version. Missing these steps can leave your extension in a broken state, and you won't find out until a query fails in production. The third trap is the sneakiest: collation changes. These can affect the order of text data, and indexes may need to be rebuilt when the collation of a column changes, as the index order is based on the collation.
Wait, rebuild indexes? How does a collation change do that?
Collations define how text is sorted and compared. If the underlying collation library, glib on Linux, or ICU if you're using ICU collations, changes its sorting rules between the old and new Postgres versions, any B-tree index on a text column using that collation may be sorted in the wrong order. The index structure is intact, but the sort order can be invalid, so index scans can return wrong results or miss rows entirely.
So queries may return incorrect results due to index order inconsistency with collation changes?
Exactly. This is why collation changes are so dangerous. Postgres doesn't know the index is inconsistent. It looks fine in the catalog. You'll only notice if you get wrong query results or if you run a manual check. You need to use PG upgrade with the check option or manually verify collation versions and then re-index affected indexes. Always run PG upgrade with check first to identify potential collation issues before you commit to the upgrade. You can also query PG collation and check the conversion column against the actual library version using PG collation actual version. Once you've identified affected indexes, you must IRI index them, preferably with IRI index concurrently so you don't lock the table, and critically, test your queries before and after to make sure the results match.
How common is this?
It depends on your OS and Postgres versions. Gile by C collation changes have happened between major OS releases, for example, upgrading from Ubuntu 18 to 20 or RHEL 7 to 8. ICU collations are more stable but can still change. If you're upgrading Postgres and your OS at the same time, you're at higher risk. Always use, check, and re-index proactively if there's any doubt. This query finds indexes where the stored collation version doesn't match the current library version. It checks the indexes collation array against PG collation to find which indexes use collations, then compares the stored collation to what PG collation actual version returns. Any mismatch means that index needs to be rebuilt.
And you'd run this right after PG upgrade?
Yes. Run it before you serve production traffic. If it returns any rows, index those indexes concurrently. Don't skip this step. An inconsistent index can cause data integrity issues that are very hard to debug later. A few final tasks. If you used link mode, the old cluster's data directory is still on disk and still consuming space via hard links. Once you're confident in the new cluster, run the delete old cluster script that PG upgrade generates. Update your application connection strings and DNS entries to point to the new cluster. And if you had replication slots or logical subscriptions, you need to recreate them manually. PG upgrade doesn't transfer those.
So there's a whole post-upgrade checklist?
Absolutely. The upgrade itself is just the middle step. The preparation, checking extensions, disk space and compatibility, and the post-upgrade tasks, analyze, reindex, testing, are just as important. Skipping any of them is how you end up with a broken production cluster. If you want to catch these kinds of issues before they bite, missing statistics, plan regressions, extension health, and more, my DBA's free health check does exactly that. Connect your own database, and you'll get a comprehensive report that grades you across 16 domains with the exact runnable fixes for every finding. The first report lands almost immediately, and it keeps growing and arriving every week. Head to mydba.dev and run your free health check today.